Let's take a look at section 6.4, transformations of exponential and logarithmic functions. We look right here at transformations, horizontal stretch, shrink, vertical stretch, shrink, reflections, all that fun stuff. It's like a bad habit you just can't quit. As you try to like stop and get away from it, but it just keeps coming back like every chapter. And it's like, what's up with that? Because it's important and it applies to all the different functions that we've been looking at. So, quick rundown. We take a look right here at, what are some of these transformations? The horizontal ones. Now, what's going to shift something horizontally, if you look right here, is going to be where the exponent is, right? At the exponent where it has x plus 3 or x minus 3, that is the spot that will talk about our horizontal transformation. So you could see right there, I try to highlight that for you. When it comes to vertical transformation or a translation, now remember, horizontal is input, right? Because that is only affecting the x directly. However, for vertical, don't forget that is output, because the whole entire function is being changed or added or subtracted to. So instead of adding or subtracting to the exponent, it's adding or subtracting to the entire function itself. And so you could see right there, I circled both of them. You could see where we're adding and subtracting to the entire function or the output. Reflection, right here, when it's y-axis, okay, that, don't forget, that is input. X-axis reflection is output, and that's why the negative is put all in front of the whole entire function itself. Horizontal stretch and shrink. Now, remember, with horizontal stretch and shrink, you have to take the reciprocal. It's like the opposite of what you see right here. So remember, if it's a horizontal shrink, the equation, you see 2 times x, or 2 times the input. But that should tell you right there that we're having a shrink, okay, of 1/2. And right here, down below it, 4 raised to the x over 2, that happens to be a stretch of 2, because the reciprocal of 1/2 ends up being 2 right there. So make sure horizontal stretch shrink is always that tricky one. Next up, we have our vertical stretch and shrink. Now that one's usually, it's pretty straightforward. If it's a vertical stretch of 3, then we're going to multiply the whole thing by 3, because this right here, vertical stretch, is your output. Where the whole entire function is going to be transformed. So we have output for vertical stretch and shrink. Horizontal stretch and shrink is input. So I'll go back and fill that in right there. Alrighty, let's go ahead and take a look at some of our horizontal shifts right here for logarithms. And it's pretty much the same, except we have log that's in the way. Horizontal translation, remember, that is going to be your input, meaning that h, that transformation or translation, is going to affect the x value. And you can see, once again, remember, you take the opposite. 4 units to the right, we have right here x minus 4. And then when it is 4 or 7 units to the left, remember, when it's going to the left, it's going this direction, and that right there will end up being x plus 7. Okay, and remember, the left, we take the opposite, because when we say plus 7, we're going to think, oh, in the number line, we're going to go to the right. But we actually go the opposite way, because when you set it equal to 0, x plus 7 equals 0, you get x is equal to negative 7 when you solve it out. So think of it that way. All right, so I think for the most part, you can kind of see how the rest of the translations work. They work just like with exponents, just like how they did with um, parabolas and radicals. They all have the same similar outcomes as long as you know the rules and whether it affects input or output. So let's go ahead and do some graphs here. Remember, one of the things you should do is make a table as you are graphing these things to help you so I could see how you got your points. Okay. Um, not everything is always about using a graphing calculator or using a calculator. It's knowing, hey, how do I um, solve these problems logically, truly understanding the base of how things work out. And then that will definitely help you later on when you start seeing logarithms and exponents in pre-calculus, um, calculus, etc. So looking at number one, first off, I take a look at f and g of x. And the thing is to try to figure out, well, what's going on here? What is the transformation that's occurring? And that's the first thing. Let's describe the transformation. In the problem right here, I see 6 to the x power. And then in g of x, I got 6 to the x power plus 6. So that right there should tell me, hey, we have ourselves, it's affecting the output because it's added to the whole thing. And if it's output, then it's going to be a vertical translation, right? So it's vertical, and it's going up 6 units. And that would be our description of the transformation. So now let's go ahead and graph things out. Now, my base is 6, my exponent is x. That means it's not moving anywhere. It's pretty much it's very similar to the parent function. So what we can go ahead and do is, how about right here, for f of x, we can go ahead and just use basic numbers, -2, -1, 0, 1, and 2. Okay? And then you go ahead and plug things into the calculator. 6 to the -2 second power, we have ourselves 0.02. 6 to the negative first power, 0.16. 6 to the 0 power, good old 1. 6 to the first power is 6, and 6 to the second power is 36. So let's go ahead, I'll graph that function. We'll fit what we could fit here, especially because some of the numbers are big. But we have at 0, 1, at 1, 1, 2, 3, 4, 5, 6. And then at 2, 36, it's going to be way off the chart. Right here at -1, we're at 0.16. And so we can go ahead and see right here that it's going to get close to that x-axis. But it's not going to cross it. And then it shoots up. So there's our function for f of x. Let's go ahead and repeat this for g of x right here, so that we can go ahead and see both of the functions. And now for this one, because it's vertical, we can go ahead and use the same numbers, -2, -1, 0, 1, and 2. Okay, we can go ahead and do that and come up with our different points that we have here. And so plugging things into your calculator right here, when -2 goes into the function for g of x of 6 to the negative second power plus 6, that right there will end up with 6 looks like 6.02. When we plug in -1, we should end up with 6.16. And then at 0, we have 7. At 1, we have 12. And then at 2, it is 42. So you can see that we take our function and everything gets shifted up, right? 6 units. So we're at 1, 2, 3, 4, 5, 6, 7. So there at 0, 7 is one of our points. At 1, 12, it's going to be off the chart, but I'll go ahead and put like a dot that's kind of out there to kind of show that to you. But what we can see now is where we have our horizontal asymptote, and that horizontal asymptote will be at 6. Now, although my function won't look like that horizontal asymptote at 6, we can tell it is by looking at the numbers, and it's getting close to 6, but it's not going to cross that or get ever equals 6. And there you have it. We've got our graphs, we described it, we have our points, so I know where that function is. So in your homework, please make sure you put that down. You have those points listed. Okay, so let's go ahead and take a look at number 2. We'll do the same thing here. We've got e to the x power. All right, so we have that, and then in the exponent right here, well, look at here, we have x minus 4. So when it's in the exponent, well, what's going on? That should tell us we have ourselves a horizontal shift. Okay, so let's go ahead right here, horizontal shift, or horizontal transformation. And which direction is it going? Hopefully you think to yourself, and you now know automatically, that it is going to the right 4 units. All right, so that right there, pretty simple stuff that you've been doing for quite some time now. So let's go ahead. We'll plug in some points for f of x. We can go ahead and use our standard numbers, -2, -1, 0, 1, and 2. When you plug in -2 in for x, e to the negative second power is it's 0.135. -1, e to the negative first power, 0.36. E to the 0 power, good old 1. And then we have at 1, e to the first power, we got ourselves, our 2.7, and it keeps going, or, it goes out. And then we have ourselves e to the second power. We'll go ahead and round that off to 7.4. So if you go ahead and plot these points right here, our x-axis is our horizontal asymptote. And we have our function look a little something like this right here. Okay, let's go ahead and do g of x as well. And now, since g of x is actually shifting to the right 4 units, it doesn't really make too much sense to use -2, -1, 0, 1, and 2. If we're going to shift it to the right 4 units, then we should make sure that we have points that are appropriate for that. And so instead of 0 being in the middle, let's go ahead and we'll put 4 in the middle right here. And then we'll go ahead and have the points like 3 and 2, and then 5 and 6. Okay, because if you choose -2, -1, 0, 1, and 2, what's going to happen is you're not going to see the graph make that nice curve, that exponential curve. So that's why let's go ahead and move it over, and then we can go ahead and see it. We can picture everything in place. So when we plug in the numbers, I got myself 0.135. For 3, we have 0.367. When g of x, when we plug in 4, we get 1. 5 is 2.7, and then when we plug in 6, we have 7.4. So a lot of these points, they show up again because it's pretty much, we didn't do any stretch or shrink or anything like that for g of x. We just moved it. So we go ahead right here at 4. There's our point at 1. We have at 5, we're at 2.7. Go ahead and put that there. And then at 6, we're at 7.4, all the way up here. And then it comes its way back down onto the right side. And look at this magnificent graph right here that shows g of x. All right, so you can see the same graph just shifted 4 units to the right. Let's take a look at number 3. Okay, we have in our function, we have log base 5 of x, and then we have 1/2 in g of x, and then we have log base 5 of x plus 7. So there's two types of transformations going on here. Remember, if it's on the outside, like in the yellow one, then this right here represents your output. That right there, since it's less than 1, greater than 0, it's a vertical shrink. Just like that. Afterwards, we got ourselves this x plus 7, and this right here, it's attached to the x, so it's input. And then it's going to be moving 7 units, certain direction. You take x plus 7, set it equals 0, it's negative 7. So it's going to be going to the left. So second thing we can go ahead and put 7 units left. And we should also include the fact that it is horizontal. 7 units left. All right, next up. Graphing it, you should know the drill. We could start off right here. Actually, let's go ahead for f of x. You can go ahead and put negative 1, negative 2, negative 1, 0, 1, and 2. How about for g of x right here? Because it is shifted over 7 units, we could go ahead and put negative 7 for our center number. And then we have like negative 8, negative 9, negative 6, negative 5. And then from there, you could go ahead and plug in the rest of the numbers into the equation to find x. All right, so we'll kind of cut to the chase now since we have most of this down. Let's go down to number 4. We'll go to the main transformations here. We have things that I see that's different from f of x to g of x is at negative 4/3 in the equation. So negative 4/3 right here, that could tell us that this is output once again. And if it's output, then it is a vertical transformation. It's going down 4/3 units. So it's not making too much of a move, but it is going downwards. If you look, my log base is 1/3. If it's 1/3 like that, less than 1, greater than 0, just kind of giving you an idea, the log base is going to be different than what we've seen so far. And it's actually going to go downwards right here. And so I'll give you an example of how it's going to look as it goes downwards. Okay, so there is number 4. All right, let's go ahead and now take a look at number 5. Right here. Let's see. I see some stuff going on with the exponents. So let me go ahead and highlight that. That's something new. And then we also have this +4 right here. So remember, if something is being impacted with the exponent and there's a negative there, along with that 3, there's actually 2 things right there. First off, that negative should represent right here your reflection. and it's a reflection across the y-axis. And then we also have right there that 3. And remember, that 3, when it is attached to your input, it's a big deal. The reason being is because that 3 with your input tells me that we have ourselves a horizontal shrink. And that horizontal shrink happens to be not -3 or 3, but it's actually 1/3. Okay? And then the last part right here is we've got that lovely 4, and that 4 happens to be your output. And we could say that the horizontal shrink is input. So then that 4 happens to be your output, and then it is going vertically. So vertical transformation up 4 units. And that right there is all the stuff happening on number 5. And let's go ahead right here. We'll round it off with number 6. On your homework, you're going to make sure you do the graphs. I'll tell you which ones to graph in the assignment. But for now, since you know how to graph, I would hope at this point I went over the steps. You can go ahead, and I am bypassing that in the last few problems right here. So we have the -3 out in front, and then we have right here in parentheses an x minus 2. All right, so several things going on right there. That -3 should stand out to you. Okay. 1, the negative, it's attached to your output. It's on the outside. So that -3 is your reflection. But this time, this is for the x-axis. We have the 3 that's out in front. That right there will represent you have a vertical stretch. And that vertical stretch of 3 units. And then lastly, right here, we have the x minus 2. And that x minus 2 it's attached to the input. And then -2 tells me that it's going to actually go to the right 2 units. So it's horizontal transformation, right 2 units. And there you go. Another lesson on transformations, but this time with exponentials and logarithmic functions. And there you go, section 6.4.